Yeah. So in the morning session, we have covered a very important concept, that is regularization. Very basic concept. Regularization. Now we are going to complete data augmentation. What is meant by data augmentation? Why we are using data augmentation in our machine learning, deep learning, particularly deep learning program? In general, the best way of making machine learning model generalization better is training it on more data. What is the meaning of this? That means usually when we are designing a model, we need a data set. So because we need input, we are passing that input values, input data. So this input data will learn the model, applying learning algorithm, and we are predicting the output. This is general technique. So what we are doing here, it is, unfortunately, the data which is having a data is very minimal data. Machine learning applications are applies and generates the output. Accuracy is depends on how much data we are providing as an input. So when we are using a data set, which is covered in the last unit, second unit, data set. So this data set is divided into two partitions, like two categories. One data set is used for testing, training purpose. Another is used for testing purpose. Okay, now we are going to say data set augmentation, important thing. So because with less availability of a data, what is the less availability of a data? అంటే ఏంటి అంటే, say for example, మనం ఒక మోడల్ ప్రిడిక్ట్ చేయాలనుకుంది, autonomous vehicle or a robo. ఈ మోడల్ ఏం చేస్తుందంటే ప్రిడిక్ట్ చేస్తుంది, అవుట్పుట్ ని ప్రిడిక్ట్ చేస్తుంది. Say for example, in front of this robo we are passing some object. So this robo or a vehicle, autonomous vehicle, it has to detect this object. So to detect this object, we are using learning algorithm, deep learning algorithm. So this algorithm is pre-trained and given as a input. Okay, so this pre-training purpose we are using data set. So this data set is having more data points, then our prediction is more. సో అంటే ఏం లేదండి, మనకు ఒక డేటా సెట్, ఫ్లవర్స్ డేటా సెట్ ఉందనుకోండి. మనకు అన్ని ఫ్లవర్స్ గురించి ముందే తెలిస్తే ఏదైనా ఒక ఫ్లవర్ని మనకు చూపించి ఇది ఏ ఫ్లవర్ అంటే మనం చెప్తాం. లేకపోతే ఫ్రూట్స్, మనం చాలా ఫ్రూట్స్ చూస్తూ ఉంటాం. ఆ ఫ్రూట్స్ అన్ని ఫస్ట్ టైం చూసినప్పుడు వీ డోంట్ నో వాట్ ఈస్ ద నేమ్ ఆఫ్ ది ఫ్రూట్, what is the shape of the fruit, what is the color, taste, everything we don't know. So once we are knowing the thing, then we can easily identify, then we can easily predict that fruit wherever it is in the market. మనకు కనపడగానే ఇది ఈ రకమైన ఫ్రూట్ అని చెప్పేసి మనం చెప్తాం. సపోజ్ we have several fruits in a basket, so we can say this fruit is belongs to apple, banana, orange, like we can identify. So how we are identifying? Before this information is fed in our brain. Similarly, to predict the output, we have to feed, we have to train, we have to learn the model. That means mission is implement this model based on the data set. So if we have more number of data points, our prediction is more. మనకు అన్ని ఫ్రూట్స్ గురించి తెలిస్తే ఏ ఫ్రూట్ ఇచ్చినా మనం చెప్పగలం. మనకు ఫ్రూట్స్ గురించి తెలియకపోతే కొత్త ఫ్రూట్ ఏదైనా వస్తే, సే ఫర్ ఎగ్జాంపుల్ మార్కెట్లోకి ఒక న్యూ జాము వచ్చింది అనుకోండి. సో దాన్ని ఎలా ఐడెంటిఫై చేస్తాము? ఇంతకు ముందు చూడకపోతే మనం దాన్ని చెప్పలేము ఇది ఎలాంటి ఫ్రూట్ అని. సో high end data, more data is required. If we are not having more data, it is very difficult to predict the output. That is the main concept here. We are applying data augmentation. How this data augmentation is applying means, while modeling the algorithm, while designing the algorithm, we are going to consider the data set. That data set is limited in nature. So limited in nature, that's why we need to create a better model. For better performance, we have to increase this data. The increasing data directly is not possible. So we have to create fake data. So that fake data is added to the training set. So then our model will be trained with the fake data. Then it predicts the output. This is one of the simple mechanism. That means increasing the data. How we are increasing the data? Because we are having only limited data set. Say for example, I have only 1,000 images. So with these 1,000 images, it is very difficult to predict the output. So which is not available in the 1,000 images. I have 1,000 images, but I am giving input as a one input. This input is not at all belongs to these 1,000 images. మీకు స్టార్టింగ్ లో క్లాస్ లో చెప్పినట్లు ఒక ఫుల్ ఇమేజ్ రీడ్ చేసిన తర్వాత ఒక పీస్ ఆఫ్ ఇమేజ్ లో నుంచి ఒక పీస్ ఆఫ్ ఇమేజ్ ఇవ్వగానే వీఆర్ ప్రిడిక్టెడ్ దిస్ ఇస్ నాట్ యానిమల్, దిస్ ఇస్ హ్యూమన్ బీయింగ్ గర్ల్. హౌ దిస్ ఈస్ హ్యాపెన్? బికాస్ న్యూ ఇన్పుట్ ఈస్ ఆల్సో compared with the existing 1,000 images, new input, new image, and it predicts the output. So that output prediction is accurate because deep learning techniques are implemented with data augmentation. That means we are increasing these 1,000 images into the higher number of images. How we are increasing this higher number of images? That is defined by data augmentation. See, so in practice, we are having less amount of data in the market. Okay, less amount of data is available in the market. So we need to consider high data, high dimensional input X summarizes the single category of identity of the value. What is this? How we are correlating this means, this input is, say for example, we have 1,000 images. These 1,000 images are augmented. Data set is augmented. Augmented means it creates fake data based on these 1,000 images. How we are creating this fake data means, we are changing the dimension. Say for example, image is like this. I'm rotating the image certain degrees. Okay, I'm rotating this image in certain degrees, like 90 degrees. This is also image, and again I'm rotating this image 90 degrees. This is one image, and also I'm rotating this image another 90 degrees. I'll get another image. So with this one image, by using data augmentation, that means by changing the properties of the image, we are creating 3 fake images, 3 fake data elements. So with one data element, we are creating 3 fake data elements by changing the simple parameter degree. Okay, so like this we can apply X and Y. That means in X axis and Y axis. So when you consider image, you can rotate in X axis, and also you can rotate in Y axis. So like that, we are creating a bulk data with this limited data elements. So doing this, creating with the high data, with the minimum data set, creating high data set, maximum increasing the data. This technique we are calling as a data set augmentation. Such created data set is added to training set, not for the testing set. Only for training set, training purpose, to train our model with the different images. Those images are not available. So with the available image, we are creating more number of images. This is data augmentation technique. So this augmentation is used in the classification of our deep learning models. Data set augmentation has been particularly effective technique for a specific classification problem, object detection. When we are using data augmentation means, so we are not applying this data augmentation in all the cases. అన్నింటికి మనం అప్లై చేయాల్సిన అవసరం లేదు. Mostly preferable area is object detection. So whenever we want to detect object, so object detection point, we'll consider this data augmentation concept. Okay. Say for example, we have an input data elements x comma y. So we need to create new data element x comma y on this given input x. Okay. So this input x is transformed to training data set by using augmentation. Then images are high dimensional and which include enormous variety factors, variations. Many of such are easily simulated operations like a translations. That means why we are using data augmentation object detection means, particularly in the image object classification technique or object detection or image processing, all this particular image data set is having high dimensional data. High dimensional data means here it is having more number of features. Say for example, when we consider any image, I will show you one image. Like at the end, I will show you one image. Every image is having a different features like image dimensions, height, width, color, and pixels. Okay, pixels, you can consider pixels of the image. Each and every pixel is having its own feature. Okay, say for example, background of the image. Background of the image is covered only few pictures. Okay, dog image. So in particular features, dog features are there: eye, nose, tail, legs, and all. The remaining part is the background of the image. That every picture is having different dimensions. You try to understand a particular image. Okay, dog image or a vehicle, car image. You can consider car image. Okay, this is a car, say simple. So this is actual object car, and the remaining pixels occupies background, color, different colors than the actual object. So you simply remember we have high dimensional data with different pixels having different dimensions, features. So all these features you need to accurately identify when you are doing classification. One of the most important thing here it is, this augmentation is not applied or applicable for the text classification. So for example, when we are applying augmentation like letter B, in some degree, this letter B will become D. So our prediction will be differ. Similarly, when we are considering handwritten recognitions, 6 in some direction, when we are applying data augmentation, this may be converted as a 9, but wrong prediction will be happen. Okay, handwritten, written, that is character recognition task, and also handwritten recognition task. There we cannot apply augmentations, data augmentation. That's why data augmentations are used for predicting the objects, images, most probably images. Okay, and also audio video processing. That's why autonomous vehicles, they are using data augmentation, image detection, object detection. What is the object is passing in front, and while taking a reverse of a vehicle, in the camera it shows the object, what are the objects having in our backend. So based on that images, we are drive reverse and will park our vehicle, something which will be happen because of the data augmentation is used image processing to do all these things. This is the major thing. Okay. So you can apply data augmentation effectively on speech recognition. So voice recognition, in that area, we are using data augmentation because less data is available. So we need to increase the data by changing this some direction or some adding some parameters simply. Voice recognition objects, voice recognition applications, every time. Okay, simple example you can consider like your mobile, voice assisted mobile. So మీరు లాకింగ్ అన్లాక్ చేశారనుకోండి స్క్రీన్, ఆ టైంలో it takes different parameters like biometric థంబ్ బయోమెట్రిక్ తో మీరు అన్లాక్ చేసే ప్యాటర్న్ ఉందనుకోండి. ఫస్ట్ ప్యాటర్న్ ఎలా క్రియేట్ చేసింటారు, 3 times అడుగుతుంది, 3 times ఇన్పుట్ ఇస్తారు. దట్ మీన్స్ యు ఆర్ గివింగ్ యువర్ ఇన్పుట్ ఇన్ 3 times. దట్ ఇన్పుట్ ఈస్ ఆగ్మెంటెడ్. 3 ఇన్పుట్స్ ని డిఫరెంట్ లెవెల్స్ ఆగ్మెంట్ చేసి డేటాని రెడీ చేసుకుంటుంది. దానివల్ల మనము ఏ డైరెక్షన్ లో ఫింగర్ ని మనము ప్లేస్ చేసినా కూడా అవర్ మొబైల్ విల్ బి అన్లాక్డ్. స్క్రీన్ అన్లాక్ ఎలాగైతుంది అంటే ఆ ఇమేజ్ డిఫరెంట్ యాంగిల్స్ లో డిఫరెంట్ పొజిషన్ లో తీసుకుని ఆ ఇమేజ్ ఆ విధంగా కన్వర్ట్ అవడం వల్ల ఆటోమేటిక్ గా మన మొబైల్ స్క్రీన్ అన్లాక్ అవుతుంది. సో లైక్ ఇమేజ్ ఆర్ ఆబ్జెక్ట్ ఆర్ ప్యాటర్న్ రికగ్నైజేషన్ లో ఇలాంటివి మనం ఎక్కువ యూజ్ చేస్తాం. ఓకే, so this is the main thing. So when comparing machine learning, this is one of the benchmark result. That means remarkable result will be produced. That means it is important implementation. Data augmentation is one of the important implementation. Okay. So handy design dataset augmentation schemes are dramatically reduce generalization error. The machine learning techniques are implemented. That means hand designed dataset. That means it uses machine learning algorithm in place of deep learning algorithm. So we are extracting the features, and based on that we are rotating. That means we are changing the parameter. Parameter updation will be done for the identification of the image. Suppose the algorithm is performing say for example we have a data and we are using 2 different algorithms, algorithm A and algorithm B. Algorithm A is implemented normal input data as it is. Algorithm B is implementing data augmented dataset augmented by data augmentation. That means it is having actual data, that is 1000 images. Hello sir, మీరు తినేయండి, నేను క్లాస్ లో ఉన్నాను. అదే కదా చెప్పాను. నేను వస్తానండి, ఆయనకు క్యాల్కులేటర్ ఇవ్వాలి, వస్తాను. ఇస్తాను. ఓకే, రైట్ సార్. సారీ, So we are implementing two different algorithms for the data set. We are given only one data set. We have only one data set. This data set directly given as input for the model A. And after doing the augmentation, data augmentation, we are giving this data set as an input for algorithm B. When we are comparing the performance of the algorithms, by which algorithm will produce better result? Obviously, algorithm B produce better result because it is having data augmentation technique. So that means data is increased to the higher level so that image, whatever the output it is predicted, that output will be more accurate than the normal algorithm A. Like this, you need to compare and you need to implement algorithms using data augmentation technique. For that, we are using data augmentation method in machine learning algorithm and using Python. There exists several predefined data augmentation techniques, so we can apply. In which in this class I explained only degree of an image. Okay, so and also you can apply dimensions. You can reduce the dimensions of the image. That means pixel by pixel you can consider whatever the content you need, you can do that. Sometimes you can do resize the image, size also you can change. So like there exist several techniques. Those algorithms Python is having with SQL and scikit-learn package, it is supporting our data augmentation technique. So now comes into the noise robustness. It's another topic. So what is the noise robustness? In deep learning, noise is applied to input as a dataset augmentation strategy. So as I told you, we are doing data augmentation. In this data augmentation, noise robustness is one of the strategy. Like earlier we discussed the degree, that means changing the degree. Similarly, we can apply noise robustness. So what is this noise robustness? Noise robustness is nothing but we are adding some extra input to the actual input. We are adding some extra input to the actual input so that our input value will be creates another data element. So equivalent to impose a penalty to the norm of the weight value. So it is similar to adding the penalty of our norm value. So that is norm value is added like with actual value sigma into norm of value theta. So this is extra added with the actual input value x comma y with respect to theta, j equal to j theta. This is we discussed in the morning. So j theta x comma y. So with this actual input value to generate our output using function, okay, y is equals to f of x. This function is this one. You can consider parameterized function. So with this function, we are added norm penalties. So with respect to weight value. So this norm penalty is controls the model. What controls the model? It predicts the output. That means reducing the error, optimization or capacity value that will be defined. So similarly, we are adding noise to the data set for doing the data augmentation. This is one of the techniques. It is similar to this one, morning discussed topic, penalty normalization. So another way of adding noise is you can apply in different ways this noise. The service of regularization model is by adding its weight. That means directly you can add noise value to the weight value instead of adding to the input value. So while giving the input, you can add noise bias value. So that's why we are going to use AX plus B. This is B is a noise. We can say it is a bias value. So like that, you can add bias value in the input layer, or else you can add bias value to the weight values. Adding bias to the weight values is a better technique than adding bias to the input value. That means adding weight value or noise to the input value is not better procedure. Adding this noise to the weight value is gives more better procedure, because weight values are having in different levels. Input values are having only input level. So input layer, second layer, third layer, fourth layer, and output layer. So when we are adding noise to the input value X, it will be applied only one data element. When we are adding a noise to the weight value, so weight updation is done in first layer, weight updation is done in second hidden layer, weight updation is done in third layer. So every time we are updating weight value to control the model. So when we are applying noise to the weight value, this model will give more accuracy than the previous one. So you need to use noise robustness to increase the more data augmentation process. So see this, for example, we can assume that the sum of the small constants epsilon, we can consider the training label y is correct with the probability y minus epsilon. Otherwise, the model will be might not having a less correctness. So this is one of the technique, robust noise robust we are adding. You just apply this one. It is one of the data augmentation strategy. So one more strategy I explained, degree, rotation of the degree. One more strategy I told you, like changing the size dimensions. Like there exist several strategies. Then comes into the semi-supervised learning model. This is one of the learning model. As of now, we learned different learning models like supervised learning model, unsupervised learning model. What is the difference? What is the semi-supervised learning model? So when we are using supervised learning model for the classification, say for example, we have input value x1, x2, and so on, xn. These inputs are provided to the model. This is a model algorithm. Okay, this model generates the output as a classification. Say for example, this is X input is a fruit, mango, say banana. So output is, we are giving input. So based on this input, it classifies this as banana. So where second input is orange. Based on the input, our classification output will be like an orange. It classifies. So like it is classifying banana, orange, mango, and some other fruit. So like this, it performs the classification. The same way, when we apply this unsupervised learning mechanism, so what happened in unsupervised learning mechanism? Similarly, we will consider input values x1, x2, and so on, xn. It is not classifying like this. Instead of that, it is doing clustering. So it creates clusters, and whatever the input value we are given as a banana, mango, orange, all these things are classified as a fruit category, fruit cluster. So when we are giving input X, it is going to predict X1. When we are giving mango, it is going to be X2. So like this, it is doing clustering. So clustering and classification, these two are different techniques. If we are using semi-supervised learning mechanism, this semi-supervised learning mechanism is having a mixed data, and by using some condition, based on that condition, it will be works like a classification and clustering series. In this paradigm, semi-supervised learning, both unlabeled examples from P of X and labeled examples from P of X comma Y. That means unlabeled data, unsupervised learning, and labeled data, supervised learning, are used to estimate the output value y based on the input value x. Try to understand this. We are having unlabeled data. Unlabeled data is nothing but unsupervised learning. And we are having labeled data, supervised learning. Unlabeled data is probability of x. Labeled data is probability of x comma y. Okay, so using these two, we are estimating the new output, unseen output, new label, new output, which will be predicted based on the input value. So this is possible with the semi-supervised learning mechanism. That's why we are using some semi-supervised learning mechanisms in some of the applications. In this deep learning concept, semi-supervised learning is usually referred as learning application. Okay, so this learning representation is represented with h equal to f of x. What is this f of x? F of x is nothing but estimating the output. The goal is we are going to learn how we are representing this from the classes of different classes. So how we are representing this from the same class and different class, this is one of the important identification learning process we need to do. So unsupervised learning can be provided useful clue for how to group examples in representation space. So grouping is done, which is similar to unsupervised learning clustering. The clustering is done very easily. This is implemented the same thing in unsupervised learning. So this is a major thing which we are implementing here in semi-supervised learning. These are all very simple things, theoretical one. You try to understand theoretical concepts. I will share you material by the end of the month. Maybe within 4 days, 5 days, I will share third unit material. Okay. So with this, I'm going to stop the session because multitask learning is having little complex thing. I will explain this thing multitasking in the next class tomorrow.